Bismillahirrahmanirrahim. Today I'm going to talk about extraction of metals, extraction of iron from its ore, and extraction of aluminium from its ore. First of all, we will talk about extraction of iron. What is the ore of iron? يعني iron in the nature. What is the ore of iron? Iron exists in the nature as aluminium as the Fe2O3, iron oxide. Okay, this is called hematite. Hematite. So this is iron ore. Iron ore. In paper 4, sometimes he asking me about what is the ore of iron, so I can say ore of iron is hematite, and its formula is Fe2O3. Fe2O3. What we need to know, what we need to do here, we need to extract iron from iron oxide. Okay, so this is the ore of iron. We use this apparatus which you can see in the slide here. This is called blast furnace. Blast furnace. What will we do? Here, down, okay, hot air in, and here, hot air in as well. And I will add from the top of the blast furnace 3 components together. I will add Fe2O3 and coke. What is coke? Coke, this is carbon. This is carbon. And I will add calcium carbonate. So how can we produce iron from iron oxide? We use this apparatus, which you can see, and I will add from the top of this blast furnace, I will add mixture of Fe2O3 coke, which is carbon, and calcium carbonate. Here down, hot air enter, and here hot air enter as well. Once you add the mixture, here carbon in this area down, carbon will react with oxygen as hot air enter from here and from here. In this area, I have the first equation. What is this? The first equation, carbon will react with oxygen to form carbon dioxide. Carbon dioxide. As you see here, the temperature is 1,400 degrees Celsius. 1,400 degrees Celsius. So this is exothermic reaction. Exothermic reaction. Okay. And in the same time, this is oxidation reaction. Oxidation reaction. Okay. So why reaction between carbon and oxygen in this area is exothermic reaction? Because it increases the temperature to be 1,400 degrees Celsius. The same reaction, why this reaction is oxidation reaction? Because here carbon gain oxygen, and instead of carbon, it converted to be carbon dioxide. So this is oxidation process. Oxidation process. I'm still adding from the top of the blast furnace carbon. So equation number 2, I'm still adding carbon. It will react with carbon dioxide, CO2, to form 2CO, which is carbon monoxide. Carbon monoxide. So here will form carbon monoxide. And in the middle of the blast furnace, we have carbon monoxide, but at the bottom of the blast furnace, there is carbon dioxide. That's okay. So here, next or second equation is carbon with carbon dioxide will form 2CO, will form TCO, 2CO. Here, at the top of the blast furnace, here, at the top here, iron will react with carbon monoxide. Okay, so the third equation is reaction between Fe2O3 and CO to form 2Fe gas CO2. Okay, so here this is a 3CO, and I have to put a 3 here to be balanced chemical equation. That's okay? So now here I have iron. So I extracted iron from iron oxide. That's okay? So again, how can you extract iron from iron oxide? I will add from the top of the blast furnace mixture of Fe2O3, coke, which is carbon, it's merely carbon, and calcium carbonate. That's okay? When you add the mixture will go down here. There is hot air enter. Carbon will react with oxygen to form carbon dioxide. Then, number 2, carbon will react with carbon dioxide to form carbon monoxide. Number 3, hematite, which is Fe2O3, will react with carbon monoxide to form iron and carbon dioxide. So in this area here, we have carbon dioxide. And here in the middle, in the middle of the blast furnace, there is carbon monoxide. At the top of the blast furnace, there is iron 4. Okay? Iron 4 will be in molten state. So iron will go down. I can extract iron from this hole at the end of the blast furnace. So I understood what is the importance of Fe2O3. We can extract iron from Fe2O3. I understood what is the importance of carbon. Carbon react with oxygen to form carbon dioxide. Then carbon react with carbon dioxide to form carbon monoxide, which is very important in the extraction process. But the most important question is, what is the importance of CaCO3? Why you add CaCO3? I can say here in equation number 4, CaCO3 by heating, because the blast furnace is very hot, it will form CaO gas CO2, and this is thermal decomposition reaction. From 5 years ago, there was a question about CaCO3. When CaCO3 decompose to form CaO and CO2, what is the name of this reaction? This is thermal decomposition reaction. Okay, so number 5, the last equation with me. There is impurities with hematite. There is impurities with iron. How can you remove these impurities? Okay, the main impurity with iron is sand, which is silicon dioxide. So SiO2, which is impurity with the iron, will react with CaO, which is calcium oxide, which came from thermal decomposition of calcium carbonate to form CaSiO3. CaSiO3, which is known as slag. So this is slag. So I can say the most important part for CaCO3 decompose to form CaO and CO2. CaO will react with the impurities. What is the impurity with iron? This is sand, silicon dioxide to form slag. So by these reactions, I can say from here, from equation number 3, I extracted iron by a reaction between hematite and carbon monoxide. And in equation number 5, I remove impurities by a reaction between calcium oxide and silicon dioxide. These 5 reactions very, very important, and you must be aware about what is the name of this chemical reaction. The first one is oxidation reduction reaction, redox reaction. Why? Because here carbon gain oxygen to be carbon dioxide. So this is a redox reaction. Redox reaction. Equation number 4 is called thermal decomposition reaction. Thermal decomposition reaction between calcium carbonate decomposed by heating to form calcium oxide and carbon dioxide. Here, in equation number 5, there is a reaction between SiO2, which is non-metal oxide, so this is non-metal oxide, react with metal oxide, CaO, this is metal oxide, so this is neutralization reaction. Why we can say this is neutralization reaction? Between non-metal oxides are acidic, metal oxides are basic. In a reaction between acid and base, this is called neutralization reaction. If I need to check question about extraction of iron, I can check here with you. Question about extraction of iron. How can you write a question, or how can the examiner asking you about extraction of iron? So may I ask Abdurrahman to read the question here, then explain. Okay, Abdurrahman, go ahead. Read the question.
Iron is extracted from its ore hematite in the blast furnace.
That's okay. Here.
Describe the reactions involved in this extraction. Include your description and equation for the redox reaction and one for an acid-base reaction.
Yes, so what he needed from me, to write the chemical equation which I said before. As you see here, this is the ore which I said we add at the beginning of the extraction, which consists of carbon, which is C, iron ore, which is Fe2O3, calcium carbonate, which is limestone. So what is the first equation I said? Do you remember? What is the first equation I said? What is the first equation I said? Number 1, what I said as the first equation?
C plus O2.
Yes, the first equation, carbon will react with oxygen. Carbon will react with oxygen to form CO2. And this is a redox reaction. Okay. Number 2. Do you remember number 2? Do you remember number 2?
C plus CO2.
Yes. Number 2, carbon will react with CO2 to form 2CO. This is true. So we get 1 mark here about what I said, redox reaction. Mark number 2 for this chemical equation. Number 3, what will happen in number 3? What will happen in number 3? This is very important in the extraction process. So here, if E2O3 will react with the 3CO to form 2Fe gas 3CO2. So here, now I got ion here. Okay, so here I got an ion. I take ion here. So this ion which I need. If you check at the top, what is it? I'm talking about this one. Okay, what I added here? CaCO3. CaCO3. So equation number 4 is talking about CaCO3. CaCO3. Okay? What will happen in CaCO3? You do remember? Equation number 4. What will happen for CaCO3? What will happen for CaCO3?
So
Yes, Habiba, yes, you can say?
CaO plus CO2.
Excellent. CaCO3 will decompose to form CaO gas CO2. So here the products are CaO gas CO2. This is called, what is the name of this chemical reaction? There is a specific name for this chemical reaction, which is, what is the name? Compound decomposed by heating. So what is the name of this reaction? Is thermal decomposition reaction. So this is thermal decomposition reaction. Okay. Now, can I ask about what is the importance of CaO? What is the importance of CaO? I added calcium carbonate, which is limestone, because it decomposed to form CaO gas CO2. Why? Why I need CaO? What is the importance of CaO? What about impurities? CaO, which is calcium oxide, react with SiO2, which is sand, silicon oxide, this is impurity in iron, to form CaSiO3, which known as slag. This chemical reaction known as acid-base reaction. Acid-base reaction. Why? Because CaO, this is a base because it's a metal oxide. SiO2 is acid because this is non-metal oxide. So this is acid-base reaction. He said in the question, in your description, an equation for a redox reaction, I said the first equation is a redox reaction, that's one, and one for an acid-base reaction. So the last equation about acid-base reaction, CaO, this is basic, SiO2, this is acidic, to form CaSiO3. Got it? So these are the chemical equation for extraction of iron from its ore. What is ore of iron? Ore of iron is hematite, which is Fe2O3, iron oxide. So kindly in a paper, write these chemical equations again by your handwriting, then send it to my WhatsApp, because this is very, very important. So start please to write these chemical equations in a paper, then send it to my WhatsApp now. So start. Who finished his equations. That's okay, Habibi. Number 1, number 2, number 3, number 4, number 5. Excellent. MashaAllah. Bravo. What I can say here about these reactions, you must be aware about the name of this reaction. Number 1 is a redox reaction because carbon has been oxidized, because carbon gain oxygen in the chemical reaction, which you can see in equation number 1. That's okay? In equation number 4, this is thermal decomposition reaction because calcium carbonate, which is limestone, can decompose by heating to form CaO plus CO2. In equation number 5, this is called acid-base reaction. Sometimes it's called neutralization reaction because it's a reaction between metal oxide, which is a basic, and non-metal oxide, which is acidic, to form slag, CaSiO3. That's okay, Abdurrahman. Got it, Abdurrahman? Can you explain for me, open your mic, Abdurrahman, and tell me what are the steps? What are the steps? What are the chemical equations to produce iron from its ore hematite? So go ahead.
C plus O2 gives carbon dioxide.
Yes.
C plus carbon dioxide is equal to 2CO. Fe2O3 plus 3CO gives 2Fe plus 3CO2.
Yes.
CaCO3 gives CaO plus CO2, thermal decomposition reaction. CaO plus SiO2 gives CaSiO3, slag.
Yes. It's okay. So can I ask a question here about the slag? Look, you can see now the slide. It's up for you. What would happen if there is no slag? What would happen if there is no slag? What would happen if there is no slag? Check here. Look, you can see molten slag. Here, molten slag here. Below molten slag, we have molten iron. My question is, what would happen if there is no molten slag? Habiba, do you have any idea?
No, Mr.
Look, molten slag here above iron. You can see iron here down. Above iron, there is a molten slag. Imagine with me, there is no molten slag. You know what will happen? Iron will react with the hot air to form iron oxide again. So I started with Fe2O3. And unfortunately, at the end, after I formed iron, react again. Iron react again with oxygen to form Fe2O3. Okay, so the presence of molten slag here is very, very important. You know why? Because molten slag prevent molten iron from reaction with oxygen. Okay? Because the molten slag prevent the molten iron from reacting with oxygen. So no oxidation takes place. Got it, Habiba? Can you tell me what is the importance of molten slag?
So the molten iron doesn't react with the hot air.
Yes. Imagine with me, there is no slag here, so iron will be in direct contact with oxygen. It will form Fe2O3. But we know I don't need Fe2O3. I need iron alone. So this is what I need to say about extraction of iron. Any question, any comment about that? Any question, any comment about extraction of iron? Everything is okay? Everything is clear?
Yes.
So this is number one. What is the most important parts in extraction of iron? Number one, you have to know what is iron ore. You know, this is hematite, which is Fe2O3. After that, you have to know what are the chemical reactions. Which one is the redox reaction? Which one is thermodecomposition reaction? That's okay. And which one is acid-base reaction, or sometimes they call neutralization reaction. And finally, you must know what is the importance of molten slag here. molten slag is a defense, for iron. It protects iron from reaction with hot air. So this is the first one you must be aware about metal extraction process. Here, the first equation, which you can see, second, third, and so on. Now, in most of my sessions, I prefer to share a video about extraction of iron from a blast furnace. Okay, so now you understood what are the chemical equations, what is the ore, which one is acid-base reaction, which one is neutralization reaction, which one is a thermal decomposition reaction, and so on. So now I'm going to show my screen. I'm going to share my screen to check a video about extraction of iron by blast furnace. So are you ready? Everyone is ready now? Now I'm going to share my video. So this one. So I have to get skip. So 3, 2, 1. I'm going to share. Kindly check your screen. Is it okay with you or not? Screen now. Is it okay? Yes. Now, to me. Is it a clear screen? You can see the screen?
Yes.
Okay. So listen. I think I share the sound or not. Yes, share the sound. So why there is no sound? So look here.
In a blast furnace,
Again, okay.
applications. A. Extraction of iron from its oxides. In a blast furnace, oxide ores of iron, after concentration through calcination or roasting, are mixed with limestone and coke, are fed from its top. Hot air is blown from the bottom of the furnace and coke is burnt to give temperature up to about 2200 Kelvin in the lower point itself. The burning of coke therefore supplies most of the heat required in the process and will be oxidized to CO. The CO and heat moves to upper part of the furnace. The upper part, the temperature is lower and the iron oxides Fe2O3 and Fe3O4 coming from the top are reduced in steps to FeO. Limestone is also decomposed to CaO, which removes silicate impurity of the ore as slag. The slag is in molten state and separates out from iron. Thus, the reduction reactions taking place in the lower temperature range and in the higher temperature range depend on the points of corresponding intersections in the delta R G minus versus T plots. These reactions can be given as follows. At 500 to 800 Kelvin, lower temperature range in the blast furnace, 3Fe2O3 plus CO gives 2Fe3O4 plus CO2. Equation 11. Fe3O4 plus 4CO gives 3Fe plus 4CO2.
So Regarding the equation, just know the equation which I said before at the beginning of the session. But I need from you to see the blast furnace. This is the coke, which is carbon. This is the blast furnace, which you can see. Look here, C plus O2 to form CO2. Now this is exothermic reaction. The temperature is 1,400 degrees Celsius. Look, very, very high temperature to forget these reactions, but attention about the reaction which you wrote before. So this is the blast furnace. Number two, which I need to look about, is extraction of iron from its ore. I said extraction of iron. So number two is extraction of aluminum from its ore. Extraction of aluminum from its ore. So you can see the screen now. In the extraction of aluminum from its ore, we can use electricity. We can use electricity. Electrolysis process. I have the cell here. I have a steel tank. This is a steel tank which act as cathode. Okay, so this is a steel tank which act as cathode, which is a negative. And here I have blocks of carbon. These are blocks of carbon which act as anode. As you see, this is positive. So I have here cathode, and here I have anode. Ore of aluminium is bauxite. Ore of aluminium is bauxite. Bauxite is aluminium oxide, Al2O3. So in the nature, you cannot find aluminium alone. You cannot find aluminium alone. You will find aluminium combined with oxygen in the form of aluminium oxide, which is known as bauxite. What we need to extract aluminum from its ore, aluminium oxide. So I need to make electrolysis for this process. Aluminium oxide is a solid. If you need to melt aluminum oxide, we need 2,000 degrees Celsius. 2,000 degrees Celsius. This is very, very high temperature. Very high temperature. So instead of that, we will dissolve aluminum oxide, okay, in substance known as cryolite. So why we use cryolite? Cryolite, this is a chemical substance used to melt aluminum oxide. Why? Because cryolite decreases the melting point. Cryolite decrease melting point of Al2O3 from decrease the melting point from 2,000 degrees Celsius to 900 degrees Celsius. Okay, so number one, it decreases the melting point from 2,000 to 900 degrees Celsius. Number two, cryolite increase conductivity. It's okay? So in paper 4, a lot of questions we have about cryolite. Why we use cryolite? Because cryolite decreases the melting point of aluminum oxide from 2,000 to 900 degrees Celsius. Number two, to increase the reactivity. So what will happen here inside the cell? So Habiba, what is the importance of a cryolite? Why we use a cryolite? Two reasons. Can you tell me what are two reasons? Habiba? Okay, she is not here, I think. Abdurrahman, why we use chloride?
To reduce the melting point, the melting point of aluminium.
Yes, to reduce or to decrease melting point from 2000 to 900 degrees Celsius. Okay, number 2, why we use chloride? To increase to increase conductivity. To increase conductivity. So number 2, what? Can you tell me what is number 2? What is number 2?
Meaning to increase conductivity.
Yes, so 1 mark for each one. Conductivity means conduction of electricity. Conduction of electricity. So here I have aluminium oxide. Aluminium inside the cell. Now I have aluminium ions, which is 3 positive. And I have here oxygen ion, which is 2 negative. Now, what is the equation at cathode? What is the equation at cathode? Number 1, at cathode. Which one attracted to cathode? Which one attracted to cathode? Is it aluminium positive or oxygen negative? Of course, aluminium positive attracted to cathode by this equation. So Al, 3 positive to gain 3 electrons to form aluminium. Okay. Number 2, what will happen at anode? Number 2, at anode. At anode, oxygen attracted to anode because oxygen is negative, attracted to anode, which is positive. So here, 2 oxygen negative, 2O minus 2, 2 minus. Okay, so it will use to produce O2 gas for oxygen, for electrons. So again, in the electrolysis of aluminum oxide, what are the ions I have here? I have aluminium, which is 3 positive, oxygen, which is 2 negative. At the cathode, aluminium positive 3 gains 3 electrons to form aluminium. So I can take molten aluminium out from here. What will happen to oxygen? Oxygen attracted to anode, which is positive, to form O2 plus 4 electron. So here, as you can see, there are oxygen, bubbles of oxygen gas. And I said at the beginning, the anode is carbon anode. Carbon anode, this is carbon, and there is oxygen beside the anode. So carbon react with oxygen to form carbon dioxide. So there are 3 chemical equations in the extraction of aluminium. Okay, number 1, aluminium is 3 positive, attracted to cathode, which is negative cathode, to gain 3 electrons and produce and form aluminum. Number 2, oxygen, O2 negative, attracted to anode, to form oxygen plus 4 electron. And here we have bubbles of oxygen. It will react with blocks of carbon to form carbon dioxide. Yes, okay. So how many equations, Abdurrahman, we have? Can you tell me? What is the first one?
Cathode
Yes.
Al3 plus will lose 3 electrons
Well,
to
gain is
be
gain is 3 electrons. Yes, gas. I said of gas, so it gain is 3. So you say it again. Are you with it again, please?
Al3 plus will gain 3 electrons to be Al.
Yes. At the
And the
anode,
anode,
what will happen?
anode 2 oxygen. Oxygen will lose 2 atoms.
We'll use 4
Become
electron and form. We'll use 4 electron and form O2.
CO2.
And here there is oxygen gas beside carbon, so they react together to form CO2. So these are the reactions in extraction of aluminum. So in your chat books or in a paper, write these reactions, then send it to me in my WhatsApp now, in a paper. Write reaction of extraction of aluminum. Write this equation, then send to my WhatsApp. Write on paper, of course. Rahman, did you finish? Did you
I am
finish?
sending it.
Yes.
انت المفروض نكتب ده صح؟
Yes. A reaction
محتاج.
at cathode وفي 2 reactions at anode.
اوكي.
Yeah. Go ahead. That's okay. Both of you are correct. Yes. So this is about extraction of iron and about extraction of aluminum. So you have to remember why we use cryolite for two reasons. Number one, to decrease the melting point from 2000 to 900 degrees Celsius. Number two, to increase conductivity, of the solution. So this is our session today. Any question, any comment about what we said? Do you have any question? Anyone have any question?
No.
خلاص كده احنا خلصنا topic الميتال. Topic الميتال is done for me. Okay. Any question? Any comment?
No.
Inshallah, next session we will start with, inshallah, we will start with a new topic, which is chemistry of the environment. Chemistry of the environment. Any question, any comment finally?
No.
So there will be a homework about what we said today. Video will be on Telegram. If you have any question, feel free to ask me anytime. Thank you for listening. Wassalamu alaikum wa rahmatullahi wa barakatuh. Assalamu alaikum.